Well, maybe if I pick tools. No? Blue thing to the left. My right. Over here? That one? No. Oh yeah, maybe that. Yeah, see, now it wants to correct me. I'll figure it out. Okay, so neon. How many electrons does neon have? It's got 10. How many protons does neon have? 10. Okay? So when I go to draw out the dot structure, and that's what you're looking at there, the dot structure of neon, I'm going to put just neon in the middle, but what do I have in the middle? What is the middle anyway? It's a nucleus. What's there? Protons and neutrons, okay? And then these little dots on the outside represent electrons and the energy levels in which they live. Yes? Okay. So, of course, the first one is only going to be able to take how many? 2. And where am I going to put the rest of the 10 total? In that outer shell. So for a total of 8. Is this a happy element? Yeah? How come? How do you know that? He's got a full outer... What are the electrons called in the outer shell? There's a fancy name. They're called valence electrons. So that group number at the top tells us the number of valence electrons in each of these elements. So I can write a dot map for anybody. Say I go to oxygen. Look at this guy down here. Yes? All right, look on your periodic chart. How many protons does oxygen have? 8. How many electrons does it have? 8. Okay, so 8. I'm going to put 2 in the first one, and then what's left? 6. So how many valence electrons does oxygen have? What group is it in? 6. Look at the group number at the top of the column. Yes? You see why it's in group 6? Because it has 6 what? Valence electrons. No matter what number you pick on here, you're going to get the same thing. How about sodium? Go over and look at sodium before we draw it out. Just go find it on the periodic table. What group is it in? 1. How many electrons does it have? 11. So we're going to put 2 in the first energy level. Then how many can the next energy level hold? 8. And what do we have left? 1. So we put that in the third orbit. Yes? So how many valence electrons does sodium have? What group is sodium in? Yes? The number of valence electrons in any given atom or element is going to determine its reactivity. Yes? That's why things react with each other. That's why things join together. They're trying to give each other something they need, stability. If I have sodium over there and chlorine over here, are they going to react with each other? No. How come? The other factor to reactivity is proximity. So if I put a sodium way over in that corner and a chlorine way over in this corner, even though they're very highly attracted to each other, is anything going to happen? No. So they also have to get close enough to each other to react with each other. So the next part of the book is going to talk about the role of electrons in chemical bonding. And there's different types of chemical bonding. What's a chemical bond? What's a chemical bond? Do you think helium and neon have a chemical bond? How come? They're not what? They're not attracted to each other. Yes? So they can be as close as they want to each other, but are they going to bond or attract each other? No. There's no need. They're both happy. But if you look up on this diagram, we see two guys that aren't quite happy in their present form. One's sodium and one's chlorine. Now, how many valence electrons does sodium have? What group does it live in? 1. How many valence electrons does it have? What's it want to have? 8. How about chlorine on the other end? How many valence electrons does chlorine have? 7. What does it want to be happy? 8. Maybe we can do something for each other, sodium and chlorine. Yes? You probably used some sodium chloride today, didn't you? I bet you some of you have. Or yesterday or the day before. What's sodium chloride? Table salt. Yes? And sodium, with its 1 valence electron, if it maybe gave it up and got rid of it and gave it to somebody else, like, I don't know, a nearby chlorine, would it be happy? Would chlorine be happy? We would form something called a salt. This is a form of bonding, attraction between the two. The two are now going to be close together. They're going to hang together. They're going to be attracted to each other because of what they've done for each other. This is a chemical bond. And the chemical bond is dependent on what? Yep, proximity for sure, how close they are to each other. What else? Valence electrons. So if you look on the periodic table, and you are wicked smart, could you tell me really quickly another salt that might form very easily if the proximity of these two atoms makes it so? How about lithium chloride? Do you think that exists in our environment? Yes, it does. How about lithium bromine? Br. Sodium fluoride. Does that exist? Yeah. How come? Because everybody in group 1 has what? 1 valence electron they're looking to get rid of. And everybody in group 7 is looking for another electron to be happy. So we form something called a salt. So sodium gives up that electron, and chlorine takes up that electron, and now we have formed something called an ion. And what's an ion? Is it on this chart? No. Who's on this chart? Elements. But sodium is an element. It's a neutral element. Sodium, after it's reacted with chlorine, is no longer a neutral element. It has a charge. It's an ion. Because it got rid of a negative charge, it has 1 less negative charge than it does a what? Positive charge. So it forms a positive ion. It forms something called a cation. A cation is a positively charged ion. It's still an element, but it's not a what element? It's not neutral anymore because it reacted. How about chlorine? It's also an ion, but we call it an anion. What's an anion? A negatively charged ion. So this is one type of attraction between atoms or elements. Okay? It's called ionic bond.